So here are two sequences which are very similar. The one on the left has three premises: if P then Q, if Q then R, P, therefore R. The one on the right, the same first two premises: if P then Q, if Q then R, then the conclusion is if P then R. So I'll do the first one. It's very simple proof. Here are our three premises which we assume to be true. We're trying to prove R, and R is the consequent of the second premise, so we can get it if we have the antecedent of the second premise, Q. And Q is the consequent of the first premise, so we can get it if we have the antecedent of the first premise, P, which we do. So all we do is Q. That's 1, 3, arrow elimination. The rule that allows us to prove the consequent of a conditional, in this case Q, from the conditional and from its antecedent P. So we use 1 and 3 to do that. Then on line 5 we prove R, the consequent of the conditional on 2, because we have its antecedent Q on 4. So we've used 1, 2, and 3. So that is the proof. Now, with this one, we have the same first two premises, but that's it. And what we're trying to prove is a conditional. And this is where we use the rule arrow introduction. Now, the way the arrow introduction works is basically in 3 steps. The first thing we do is assume the antecedent. That means assume the antecedent of the conditional that we want to prove. In this case, the conditional we want to prove is if P then R. And so we assume P. And here we write an assumption, same rule, assumption, but the reason we're making it is for arrow introduction. Like any assumption, we give it the number of the line on which the assumption is made. So that's the first premise: assume the antecedent of the conditional you want to prove. Then you prove, anyhow you can, the consequent of the conditional you want to prove. And that is R. And as we can see from the proof on the left-hand side, that's easy enough to do. First we prove P, 1, 3, arrow elimination. And then we prove R, 2, 4, arrow elimination. So on line 3 we assumed the antecedent of the conditional we want to prove, if P then R. On line 5 we've proved the consequent of the conditional we want to prove, which is R. The third step is the one where we discharge the assumption. What that means is we no longer claim 3 as an assumption. What we say is, given that on line 5 I was able to prove R on the assumptions of 1, 2, and 3, what I have proved is actually on assumptions 1 and 2, if P then R. Here I write 5, the line number where the consequent was proved, arrow introduction, and in parentheses here I put the number of the assumption that is being discharged. What does it mean to say it's discharged? Well, if you look at line 5, it says if the assumption on 1 is true, and the assumption on 2 is true, and the assumption on 3 is true, then R must be true. What line 6 says is if the assumption on 1 is true and the assumption on 2 is true, then this sentence, if P then R, must be true. So instead of having P as an assumption on which R rests, P sort of crosses into the sentence and becomes the antecedent of the conditional on line 6. So the sentence on line 5 becomes the consequent, and the assumption that was made for arrow introduction becomes the antecedent. So when you discharge the assumption from step 1, where you assumed the antecedent, right, you make it the antecedent. Of a conditional that has the consequent from step 2. So this 3-step procedure: you assume the antecedent of the conditional you want to prove, you prove its consequent with the help of that assumption, or maybe not with the help of that assumption sometimes, and then you discharge the assumption, the extra assumption you made, because it goes from being an assumption on which R rests to the antecedent of a conditional that has R as its consequent. So the logical work is the same: 1, 3, arrow elimination, 2, 4, arrow elimination. But having proved R with the help of the extra assumption P, we then give it up. We give up that assumption. It goes out of the assumption set, but that's because it moves, so to speak, into the antecedent place in this hypothetical conclusion, if P then R. I showed that if P then R must be true by assuming P and with its help proving R. And so that is the rule of arrow introduction.